Okay, so previously we talked about simplifying radicals, and then we talked about adding and subtracting radicals. So now we're going to talk about the multiplying and dividing of radical expressions. Okay, it's actually pretty simple. The only main thing that I need you to remember is to always simplify. Okay, and so what you need to do is remember also you multiply outside numbers with outside numbers and inside numbers with inside numbers. Okay, so what I mean by that is 10 and 5 are both inside of the radical, and I'm literally just going to multiply the two inside numbers together. So unlike adding and subtracting where you need like radicals and you can't combine the insides, multiplying is different. They could be different, and I'm going to change the inside. I'm going to combine the insides. So I'm going to multiply 10 times 5, and it's going to stay in the square root, and it's going to be the square root of 50. Now, once you do that, you have to make sure, is there a perfect square that goes into 50? Well, yeah, the square root of 25 times 2, right? I could split this up and simplify further. And I know the square root of 25 is 5, so my final answer is 5 root 2. So always make sure you simplify. Okay, it's very, very important. So in number 2, I have some outside numbers and I have some inside numbers. So outsides with outsides. So you remember this is a -1, so I'm going to multiply -1 times -3 because they're both outside of the square root. That's going to be +3. And then you're going to multiply 2 times 10, and those are going to stay inside of the square root. Okay? And then you got to simplify. So I have to break up 20 into a perfect square times some number. So I know 4 goes into 20 5 times. So the square root of 4 is 2. Remember to multiply by that 3 on the outside. So 6 root 5 is my final answer. Okay. So I want to teach you a trick. When you multiply a square root by the same exact thing, the square root goes away and you're left with the number inside. Okay, so what I mean by that is these are exactly the same and the number inside is 3, so the answer is going to be 3. And let me tell you why. That's because I'm creating a perfect square by multiplying the same number together, right? We know a perfect square is created from that, like 4 times 4. That's a perfect square, that's 16. 5 times 5, that's a perfect square, that's 25. Well, 3 times 3, that's 9. Well, what's the square root of 9? That's 3. So if you remember this trick, you could jump straight to the shortcut and you don't have to simplify, right? So the square root of 3 times the square root of 3, that's 3. I could do the square root of 10 times the square root of 10, that's equal to 10. I could do the square root of a smiley face times the square root of a smiley face, that's going to be a smiley face. So any square root times itself is going to be whatever's on the inside, and the square root is going to go away. I could do the square root of Miss P times the square root of Miss P, and the answer is going to be Miss P. Okay, so those little tricks will pop up later on in the lesson, and I'll show you the shortcut there. So for number 4, I'm going to multiply the outside numbers together, so that's just 7 times 1. And then I'm going to do 15 times 6 because they're both inside. So that's going to be 90. And then you have to do b to the 3rd times b. Remember, you add your exponents, so that becomes b to the 4th. Well, now I have to simplify. So I have to find a perfect square that goes into 90. So think of your perfect squares. You could pull out your notes from the other day with your perfect squares list. But I know that 9 is a perfect square that goes into 90. And b to the 4th I don't have to touch because that's even, so that's a perfect square. So I'm going to take the square root of 9. That's 3. Remember, it's got to multiply by the 7. And the square root of b to the 4th, that's b squared. And I have 10 left on the inside. So I have 21b squared, the square root of 10, as my final answer. Okay, number 5, outsides with outsides, so 2 times 4, that's 8. Then insides with insides, so 6 times 3, that's going to stay inside the radical, so that's 18. N to the 3rd times n, add your exponents, that's n to the 4th. Now, if you don't want to keep rewriting it, you could do my little trick where I break it up into the two numbers. So I know it's the square root of 9 times 2, and I don't have to touch n to the 4th because that's even. So the square root of 9 is 3. You could multiply by the 8. And the square root of n to the 4th is n squared. So on the outside, I'm going to have 8 times 3, that's 24, n squared. And what's left on the inside of my radical is 2. Okay, number 6. So I'm going to show you the long way, and I'm going to show you the shortcut. So multiply your outside numbers. 5 times negative 1, that's negative 5. And then notice that these are exactly the same. Remember I said if you multiply a square root by the same exact square root, you're left with what's on the inside, but without the square root. So it's going to be 5n root 3. Well, then you think, well, what do I have to do with that negative 5? Well, you're just going to multiply it, and I get negative 25n root 3. Now, if you don't like that trick, you could keep that negative 5 and multiply your insides, and I get the square root of 25 n to the 6th, and then just simplify from there. Well, I know the square root of 25 is 5. Remember, whatever you pull out, you got to multiply by the number on the outside, and the square root of n to the 6th is even, so that's going to be n to the 3rd. There's nothing left in your radical, so I get negative 25 n root 3, the same exact answer. Okay, so you can use the shortcut or the long way, you'll end up with the same answer. Okay, now when you get problems like this, it tends to get a little bit easier. Literally all you're doing is distributing. That's it. Okay, so what you're going to do is multiply root 6 by the square root of 2. So multiply the two inside numbers together. That's the square root of 12. And then the square root of 6 times 5. Well, 5 is not inside of a radical, so that 5 is going to stay on the outside, and that 6 is going to stay on the inside. It does not become the square root of 30. Okay, I repeat, it does not become the square root of 30 because 5 is not in a square root. Okay, now I just have to simplify. I know a perfect square goes into 12, that's 4. So the square root of 4, that's 2 root 3 plus 5 root 6. These are not like radicals, so that's my final answer. Okay, number 8. Multiply root 10 times the square root of 2. Well, they're both inside the radical, so I'm going to combine those. That's 20. And then we'll multiply root 10 times 4. The 4 is going to stay on the outside. The 10 is going to stay on the inside. I can't multiply them together. Only outsides with outsides and insides with insides. And then let's simplify. So I could break this up into 4 and 5. Square root of 4 is 2. Root 5 plus 4. Root 10. Not like radicals. So I'm going to keep my answer as is. Okay, lastly, root 3 times negative 2 root 3. So you could either use the trick. So let me do, I'm going to do the long way and then I'm going to do the trick. So that becomes negative 2 square root 9. And then root 3 times 5 is just 5 root 3. The square root of 9 is 3. Do not leave a 3 inside of the radical. When you take the square root of a number, it's gone. No part of it is left inside of the square root. So the square root of 9 is 3, and it's got to multiply by that negative 2. So that's negative 6 plus 5 root 3. Now the shortcut to multiplying these two together is just knowing the negative 2 stays outside, and then root 3 times root 3, you're multiplying the same square root together, so you're just left with 3, and then you just got to multiply it by that negative 2, and you would get the negative 6 as well. Okay, again, if you don't like the shortcut, don't use it. You could do the long way, and you'll get the same answer. Okay, number 10 is when it starts getting really fun. Hopefully in your head right now, that magic word is popping in your head, what you have to do. And yes, we have to FOIL. Yay. Okay. FOILing is just long distributing. So all you're going to do is do 5 root 2 times root 2. And for those of you that want to do the shortcut, go ahead and do the shortcut. I'm going to do the long way for the rest of you. So that becomes 5, and then root 2 times root 2 is the square root of 4. And then you got to multiply 5 root 2 times root 2. Again, you could use the shortcut if you want, for those of you that understand it. And that's going to become, you could actually combine those, but we'll just do this for time's sake. So that's going to become 5 root 4. And then I got to do the same thing with the root 5. So root 5 times root 2, that's the square root of 10, insides with insides. And that's going to become the square root of 10. So simplify and then combine. So the square root of 4 is 2, and the square root of 4 is 2, so that becomes 10. There's no square root left because the square root of 4 is perfect square. The square root goes away. And here I get 10, and then I can combine these because those are like radicals. So 1 plus 1, that's 2 root 10. So I get 20 plus 2 root 10, and that's your final answer. Okay, number 11. This is actually a special case. These are matching, right? But one's minus, one's plus. This is a difference of 2 squares. I'll show you the long way, and then I'll show you the shortcut. And for those of you who like the shortcut, please feel free to use it. But the long way, we're just going to do regular FOIL. So the square root of 2 times the square root of 2, that's the square root of 4. The square root of 2 times 1, that's the square root of 2. Then I get negative square root of 2 and negative 1. Now let's simplify. The square root of 4 is 2. These are like terms, so this is 1 minus 1, that's 0. Remember, when that becomes 0, there's no square root left. That completely cancels out. And then I'm just left with that minus 1. So 2 minus 1 is 1, and that's your final answer. Now if you want to do the shortcut, let me rewrite it over here. Root 2 minus 1, root 2 plus 1. Hopefully you guys remember the shortcut from before when we would do the difference of 2 squares, but all you need to do is you're going to square the first term. What that means is you're doing root 2 times root 2. Okay, when you square a square root, the square root goes away and you're left with the number inside. So root 2 times root 2, or the square, or root 2 squared, is just 2. And then you're going to square this one, that's 1. And remember, we tag subtraction in between. And then my final answer is 1. So feel free to use the shortcut. Okay, remember, you square this, you square that, and then it's always minus in between, combine them, and then you're done. Okay, and then the last one, number 12. So all this is saying is this written twice. So it's not plus minus, it's literally written exactly the same twice, and then you're going to FOIL. Okay, so negative 1 times negative 1, that's 1. Negative 1 times root 5, that's negative root 5. And then root 5 times negative 1, that's negative root 5. And then root 5 times root 5, so you can use the shortcut here. Root 5 times root 5, the square root cancels out, or I'm just going to do the long way. That becomes the square root of 25. And let's combine what we can. So these are like radicals, so negative 1 plus negative 1, that's negative 2 root 5. Remember, you don't combine the insides. Now that we're adding and subtracting, do not combine the insides. Okay, I'm going to repeat that again. Now that we are adding and subtracting, do not combine the inside of the radical. Only combine the inside when we are multiplying. Okay, and then I'm going to simplify the square root of 25 to be positive 5. Not 5 root 5, not the square root of 5. You take the square root of the perfect square, it comes out of the square root. Okay, now I can combine the 1 and the 5. That's 6 minus 2 root 5, and that's my final answer. Okay, and that's it for multiplying. Hopefully it wasn't too fast for you, but if it was, please feel free to restart this video later and kind of go through it again. But the last section we're going to go through is dividing rational expressions, And again, I'm sorry, I know this is a lot, but we kind of have to condense everything together. So just bear with me. So when we're dividing rational expressions, it's the same kind of idea as multiplying. You don't need like radicals, but what you're going to do is you're going to simplify inside of the radicals together and the outside of the radicals together. Okay, so what you're going to do is first check to see, do I have a perfect square in the denominator or even in the numerator that I could simplify? And in this case, I do. So in the denominator, I see that the square root of 25 is just 5. And now some of us might think, oh, I could simplify 10 over 5 and make that 2, but you cannot, because 10 is inside of the radical and 5 is not inside of a radical. So those can't simplify. And then I just have to make sure, is there a perfect square that goes into 10? Like, can I simplify that square root further? And I can't. So this is literally your final answer. Okay, with number 4, you can, like I said, you could simplify insides with insides. So think of like if you had the fraction 6 over 75, how would you simplify that answer? Like, what number could you divide both of those by? Well, I know that 3 goes into both 6 and 75, so I could actually change this. They're still going to be inside the square root, so I could change this to the square root of 2 over the square root of 25. Now I see I have a perfect square in the denominator, so I'm going to simplify that, and that's going to become 5. I cannot simplify the square root of 2, so that's your final answer for that one. With number 5, so I have outside numbers now, so let's simplify those. So ignore, like, cover up the root 3 and the root 27 with your hand and just look at 2 over 4. If you were to simplify that as a fraction, what would that look like? That would be 1/2, right? So this is going to become a 1, and that's going to become a 2. And I could actually simplify the 3 and the 27 because they're both inside of a square root. So the 3 is going to become a 1, and the 27 is going to become a 9. So in the numerator, I actually have 1, the square root of 1, or just the square root of 1, and then 2, square root of 9. Well, hopefully you guys recognize right away the square root of 1 is always just 1. And the square root of 9 is 3, and that 3's got to multiply by that 2. So 3 times 2 is 6, and because 9 is a perfect square and there's no other number inside of that radical, there's no square root left. So your final answer is 1 over 6. Okay, let's move on to number 16. So 4 over 3. So those are two outside numbers, but they cannot be simplified with each other. So I'm going to move to the inside. So I have 20 over 125. So I know 5 goes into both of those. So I'm going to reduce those by 5. Let me rewrite this while I do that. So if I divide 20 by 5, I get 4. And if I divide 125 by 5, I get 25. And I also have some x's. So let's go back to exponent rules. We could subtract the exponents. So 3 minus 1 is 2. And since 3 is the bigger exponent and 3 is in the numerator, my x squared is going to stay up top. So this is going to be x squared in the numerator. Now let's simplify where we can. So I see in my denominator I have a perfect square. So the square root of 25 is 5. I'm going to multiply that by the 3, so I get 15 in the denominator. And then in the numerator, I actually have some perfect squares I could pull out, right? So the square root of 4 is 2, and the square root of x squared is x. Multiply that by the 4, and I get 8x. And then that's your final answer. Okay, because I can't simplify the 8 and the 15. Nothing goes into both of those. Okay, number 17. I see in the denominator that I could simplify that radical. They're both perfect squares. So the square root of 4 is 2. the square root of x to the fourth, that's x squared. So multiply those two together, that's 4x squared. And then in the numerator, the square root of 9 is 3, so I have 9 left in the numerator. Ask yourself, can I simplify those? No. So then that's your final answer for that one. Okay, and then finally number 18. I don't see a perfect square in the denominator, so let's see what we could simplify. I can't simplify the 5 and the 2 only because nothing goes into both of those. And then with 15 and 12, 3 goes into both of those. So I'm going to divide 15 by 3, that's 5. And I'm going to divide the 12 by 3, that's 4. And then I see an x to the third and an x. So the x to the third is going to become x squared. And then the y is not going to simplify with anything, so we're just going to keep that in the square root up there. Okay, so I see a perfect square in the denominator. So I'm going to take the square root of that 4. That's going to become 2. It's going to multiply with that 2 on the outside, so that's 4. And then simplify what we can in the numerator. So the x squared is a perfect square, so that becomes x. The y squared is a perfect square, so that becomes y. And all you have left on the inside is that 5. And then there's our final answer. Okay. So 6 more examples and we're done. I promise. So I'm going to teach you a little bit about rationalizing the denominator. We'll do this a lot more junior year, but I just want you to be introduced to it so it's not as confusing when you learn it junior year. So what rationalizing the denominator means is some mathematician somewhere decided we do not like square roots to be in our denominator. Okay, that's a big no-no, and we need to get rid of it. Okay, so in number 19, I can't simplify 2 with 5. 5 is not a perfect square, so now I have a square root stuck in my denominator. So in order to get rid of it, I have to multiply it by something to make the square root go away, to make it cancel out. So hopefully you're referring to the beginning of the lesson, when we saw that when you multiply a square root by the same exact square root, that square root disappears and you're just left with the number inside. So all you have to do is look at your denominator and multiply by the same exact square root. So in number 19, I see a square root of 5, so I'm going to multiply by the same exact thing, the square root of 5. But with fractions, whatever you do to the denominator, you also have to do to the numerator. And the reason why this works is this, is in the numerator, I'm going to get 2 times 5. They're both on the inside, so that's going to become the square root of 10. And let me show you on the side. If I did square root of 5 times the square root of 5, that becomes the square root of 25. And you just created a perfect square, which gets rid of the square root, right? What's the square root of 25? Well, it's 5. And that's why we multiply by the same exact radical, because it's going to get rid of that square root, and you're going to be left with the same number on the inside. And then you're done, okay? I can't simplify the 10 and the 5 because the 5's outside of a radical and the 10's inside of it. So this is literally your final answer. We just couldn't leave the answer like it was in the beginning because we can't have the square root in the denominator. It's okay to have it in the numerator. It's not okay to have in the denominator. So radical's okay up top, radical not okay on the bottom. So with problems like number 20, I can't simplify. The 3's do not cross out because 1 3's inside and 1 3's outside. Okay, so right now, all I care about is this. Ignore the 4 for right now. Okay, all I care about is getting rid of that square root of 3. So I'm not going to multiply by 4 square root of 3. I don't care about the 4. The 4 isn't inside of the square root. What I care about is the 3 inside of the square root. So you're going to multiply by just the same exact square root, not the number on the outside. So what's going to happen is this is going to become 3 root 3, and the reason why it doesn't become the square root of 9 is because, remember, this is not inside of a radical, so it's outsides with outsides, insides with insides. So 3 stays on the outside, root 3 on the outside. I'm going to ignore the 4 for now, but the square root of 3 times the square root of 3 is just 3, but you got to multiply it by that 4 that's already on the outside. So what I'm going to get is 3 root 3 over 12. And just make sure I can't simplify further. Well, I see the 3 and the 12 are both outside of a square root, so you could actually simplify that, right? 3 over 12, we could divide both of those by 3, and that becomes 1 square root of 3 over 4, and that's our final answer. So with number 21, I would simplify first, rationalize the denominator last, if that's the case. So I see a 6 and a 3 on the outside, so those can be simplified, right? 6 over 3, that becomes 2 over 1. And we can actually simplify the insides too, right? What goes into 6 and 10? Well, that's 2, so this becomes 3, and that becomes 5. So what I have right now is 2 root 3 in the numerator, and in the denominator, I have the square root of 5. Okay, well, I can't simplify further. I hate that square root of 5. I can't have it down there, so I'm just going to multiply by the same exact thing. I'm going to multiply the top and bottom by the square root of 5. So in the numerator, I'm going to get 2, and then you multiply the insides together. So that's root 15 over 5. Again, do not simplify the 15 with the 5, because the 15 is on the outside and the 5 is on the, the 15 is on the inside and the 5 is on the outside. And so that's our final answer. Okay, with number 22, let's simplify what we can. You could either reduce the x to the third with the x to the fourth, or you could take the square root of x to the fourth. I'm just going to reduce it. So I'm going to do 4 minus 3, and that's 1. So this is going to go away, and that's going to become x to the first. And I can't simplify further. I can't have that square root in the denominator. So multiply by that exact radical. Everything that is inside of that square root, you have to multiply it by exactly. So I'm going to multiply by the square root of 3x. Okay, it's got to be exactly as the denominator. Okay, so multiply your insides together in the numerator. So I get 15x. And then in the denominator, rewrite it, but without the square root. So it's just going to be 3x. Can't simplify it all because all that's inside in the numerator and everything is on the outside in the denominator, so those can't be touched. Okay, and last two, I promise. We are almost done. Thanks for bearing with me. So let's simplify our insides. So I could divide 8 and 10 by 2. So that's going to become 4, and that's going to become 5. And if you want, you could take the square root of p to the fourth, or you could simplify the 4 and the p. I'm going to show what it looks like when you take the square root of p to the fourth. So I'm going to take the square root of p to the fourth. That's going to become p squared in the numerator. But what's left inside of the square root is 4. And then in the denominator, I have the square root of 5p. Well, I'm going to keep simplifying before I rationalize. The square root of 4 is 2, so I get 2p squared over the square root of 5p. But I can't have that square root down there, so remember, to get rid of it, we're going to multiply by the same exact square root by the top and bottom. Well, up top, 2p squared is on the outside, so that's not going to change, and the 5p is on the inside, that's not going to change. And then down below, I have 5p. Now just make sure you can't simplify. Well, I see a p on the outside on the numerator and a p on the outside in the denominator, so let's simplify that. So this p is going to go away, and that's going to become p to the first. So 2p square root of 5p all over 5. Okay, last one. So I can't simplify the 4 and the 3, but I can take the square root of 4. So that's 2. So if you want, you could take the square root of m squared, or you could simplify the m squared with the m to the third. Let's do it that way this time. So the m squared's going to go away because 3 minus 2 is 1, so that's going to become m to the first. Let me just cross this out and make this a 1. and then n to the fourth, so 4 minus 1, that's 3, so this is going to become n to the third. So in the numerator, I have the 2, and then I have n to the third inside the square root over the square root of 3m to the first. Okay, so let's get rid of that denominator, or that square root in the denominator. So we're going to multiply by that same exact radical. So insides with insides, outsides with outsides. So in the numerator I get 2, and then the square root of 3m n cubed over, well, it's just going to be 3m without the square root. But I could see that I could simplify in the numerator. Hopefully you could see I could simplify this. I could break that up into n squared and n. So I'm going to take the square root of n squared, that's n, and what's left on the inside is 3m n over 3m. And then again, you can't simplify the 3m's because one's inside, one's outside. So then this is our final answer. Okay, like I said, I know this is a lot to take in, especially with rationalizing the denominator. If you don't 100% understand it, that's okay. You're going to relearn this junior year. But again, please feel free to ask me questions. Please try the best you can on your homework. And again, thank you for your patience and bearing with these super long lessons. And we are almost in the home stretch, I promise.